part of topic 5, we were doing all the square roots, right? And then this last one, we were talking about functions, okay? And we're looking more at functions today. This is inverses. You probably saw inverses a little bit in Algebra 1. Again, I always go with, I don't know how much you guys would remember how much you saw it. But, so a few definitions to get us started. But then our goal today is going to be anything to do with inverse relations, okay? Inverse relationships. So a relation, you might have heard this word before, is any set of ordered pairs x, y, where x is the independent variable and y is the dependent variable. So just a general name, if we don't know whether or not it's a function, is relation. X being the independent, that means it's the horizontal axis. It means it's the variable that just you have no control over. Okay, so like that's why x is often time, because we can't control time. Okay, y is the vertical axis, y, dependent variable. That y value depends on the x value. Okay, so, you know, if something is changing over a course of time, well, time has to pass for it to change. So that's why it's the dependent variable. Okay, now, function. It's a specific relation in which each element of the domain corresponds with exactly one element in the range. I feel like we've talked a little bit this year already about functions, but we're going to talk more. So you have that definition right there. Each element of the domain corresponds with exactly one element in the range. We'll also talk about how we can look at a graph and know if something's a function. There's a certain line test that you might remember. Maybe, maybe not. If not, we'll talk about it, I'm sure. Okay, inverse relation is formed when the roles of the independent and dependent variables are reversed. So basically when you take your x values and your y values and you switch them. That's an inverse, okay? X and Y's switch. And then inverse function notation, instead of saying f of x, we generally use this f inverse of x. And it kind of looks like f to the negative 1 power of x. But that is our general inverse relationship, okay? Now, we've got a variety of things to talk about. As I said, all related to inverses. We're going to start easy. Identify the inverse relation. And then we're going to answer whether or not it is a function. So, thoughts on what the inverse is? Based on the definition up above, what do we think the inverse is? Okay, instead of negative 2, 1, we're going to say 1, negative 2. Because what did an inverse say? It says when the roles of the independent and dependent are reversed. So you're taking your independent and dependent and switching them. Or, you want the easy words? Switch x and y. Okay, so negative 2, 1 becomes 1, negative 2. Negative 1, 4 becomes 4, negative 1. 0, 3 becomes 3, 0. And 1, 1 becomes 1, 1. Or shall I say stays 1, 1. Okay, so right there, if you're asked for the inverse, there is your inverse. Now, the question, is it a function? Let's answer, it doesn't ask, it just asks if the inverse is a function, but we're going to talk about both of these. So let's go back to the original. Okay, the original printed XY chart. Is this a function? Definition up here, each element of the domain corresponds with exactly one element of the range. Negative 2 goes with 1. Does it go with anything else? Negative 1 pairs with 4. Does it go with anything else? 0 pairs with 3. 1 pairs with 1. Do they pair with anything else? So is this original piece a function? Yeah. Each x value pairs with one y value. You might remember just saying the domain does not repeat. Okay, general rule of thumb is if your x values don't repeat, it's probably not a function. If you have an x value repeating I just said that backwards, didn't I? Yeah, but I think I just said, okay, rewind, just in case I said it wrong. I don't even know how I was saying it now, geesh. Okay, as long as the x values do not repeat, it should be a function. If my x values do repeat, there's a chance it's not a function. Okay, so this one, my original xy chart here, it is a function. Okay. Now, what about my inverse? Is that a function? Why are you saying no, Patrick? Okay, the x's repeat. What do we have happening here? 1 pairs with -2, but 1 also pairs with 1, doesn't it? Okay, so that means that my inverse is not a function. Okay, and again, it's not a function because of those 1s. Because that 1 pairs with 2 different y values. Okay, so if you want to write a note in there or draw the arrows, you know, something so that you remember why is that one not a function. Okay, B. We have an XY chart. I'm not going to read it off. Let's start with the inverse. What is this inverse relation? Nine negative 1. 7 0. 5 1. 3 2. 1 3. -1 4. All we did to find the inverse. Easiest way to find the inverse all day. Okay, if it's just an XY chart, flip them. Let's talk functions. Let's go back with, is my original a function? And I don't remember that they'll ask you that in homework, but just, you know, checking. Is the original a function? Each x value is unique, right? If each x value is unique, it can't repeat, so yes, this one is a function. What about our inverse? That's what the question is really asking. Is the inverse a function? Yes? Do any of my x values repeat? No. 9, 7, 5, 3, 1, -1. So my inverse is also a function. Okay? Whether the original, and that kind of just, you know, goes to show, whether the original is or is not a function is not going to affect whether the inverse is or is not a function. Okay? It just depends on the points. Okay. So, always an easy thing, inverses. Remember, switch your x and y. Okay? That's what you've got to be able to remember there. Now, on the bottom section, we're going to look at finding equations. So this was just, okay, here's an XY chart, find the inverse. Now it's, here's an equation, find the inverse. And then we're also going to look at graphing. So I have a few little steps for you. To find an equation of an inverse relation, switch the roles of x and y. That means you take x's and turn them into y's. You take y's and turn them into x's. Okay, you just switch them every place you see them. You're going to take that new equation, you're going to solve it for y. Okay, that's how we find our inverse. We will oftentimes then, actually it doesn't look like I did my notes, but then, you know, it's not unusual to then use your inverse notation in place of the y in the end. Okay, I don't remember, I bet Savas does not do that though. But then we're also going to look at the graph. Okay, so we're going to practice a little graphing here again. We're going to graph the original, and we're going to graph the inverse. And the point of me doing that is to show you the relationship, because a function and its inverse, or a graph and its inverse, will always be reflections across the line y equals x. You guys know what the line y equals x looks like? It's not this. It's not this. Exactly, it's the in-between. Okay? He showed me vertical, he showed me horizontal. Y equals x is that perfect diagonal line. It goes through 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. So it's not your typical horizontal or vertical reflection. It's a diagonal reflection. So we'll look at what that looks like here in a moment as well. Okay? So let's talk graph then. Let's talk function. So write an equation to find the inverse of f, graph f and the inverse of f to determine if the inverse of f is a function. Okay, so f of x equals x squared. We're going to start by finding the inverse. Well, they threw in f of x at us. What do you guys know about f of x, though? It's y, isn't it? Okay, so first thing I would do is forget this f of x stuff. Just think of this as y equals x squared. Okay? Anytime you see an f of x, you can just get it out of there, think y. Okay, now, so we have the equation y equals x squared. How do we find the inverse? The first piece of information said to what? Switch x and y. Okay, so instead of y equals, I'm going to write x equals. Instead of x squared, I'm going to write y squared. Okay, so that right there is me switching x and y. Okay, after you switch x and y, what's our next goal? We're going to solve for y. If this is x equals y squared, and I don't know, would you guys prefer to think of it as y squared equals x? Doesn't matter to me. Either way, though, how do you solve for y? How do you make this equation y equals? This is square root, right? This is first half of the chapter here. We're going to take the square root. If you take the square root of y squared, or in other words, if you take the square root of one side, you're taking the square root of the other side. Now, the square root of y squared is y. What's the square root of x? Square root of x? Is that all you guys said? What happens when you take the square root in an equation setting? You have to put on the plus or minus. Okay, so this is going to actually be y equals plus or minus the square root of x. And this is our inverse. Okay, so that is your inverse right there. That was the first thing they asked us to do. Write an equation, find the inverse of f. Okay, check that off the list. Graph f and the inverse of f. So, let's start by graphing f. Okay, what was my original f? That was the y equals x squared. How do you guys want to graph y equals x squared? I'm open to ideas. There's a couple different ways we could talk about this. If you dig deep enough, we've been there, done that this year. But there's also always the fallback option. If you don't know what a graph looks like, you can set something up. Do you know what y equals x squared looks like? You should. What is y equals x squared? I'm seeing some people mouth it, yeah. Parabola. Now, if it's just y equals x squared, it's a parabola centered at 0, 0, yes? Do you remember, if it starts at 0, 0, what's the first set of points from 0, 0? Over 1 up 1. What's the next set of points? Over 2 up 4. Yes? That's buried in your brain somewhere, right? Okay, it started to come out there. Now, so if you remember that, go for it. If all else fails and you're saying, yeah, I didn't remember that, Mrs. Sargent, sorry. Okay, no problem. I'm going to say set up an XY chart. Okay. Now, if you set up an XY chart, put some X values in. I'm going to use -2, -1, 0, 1, and 2. And that's going to give us the same result as what we just talked about. Okay. So, if you put -2 in for X, -2 squared is 4. If we put -1 in, -1 squared is 1. 0 squared is 0. +1 squared is 1. And 2 squared is 4. Okay, can you use those to graph your original function? If you haven't already graphed. So 0, 0, 1, 1, 2, 4, the reflections, -1, 1, -2, 4. Okay? And this is my original function. Okay, that's what we graphed. I don't know, that might even go back to, that goes back to first or second chapter of the year. That definitely goes back to first 9 weeks. Okay, that's my original function. So it asks us to graph f. And then it asks us to graph the inverse of f. Ideas for graphing the inverse of f. Again, I'm willing to talk options here. There's several. And we want to graph y equals plus or minus the square root of x squared. We could talk about how you're supposed to know what the square root of x graph looks like. That's the first half of this chapter. Now, the plus or minus part, the minus just means there's a reflection there. Okay. So it's the top half and bottom half. What? So the positive square root of x is the top half of the parabola. Wait, let me rephrase that. Half a parabola, but it's a half of a sideways parabola, right? What's the negative square root of x going to be? That's going to be the lower half. Now, if your brain's saying, okay, sorry, Mrs. Sargent, I didn't know that graph either. I didn't know what square root of x looks like. Okay, fine. You might want to figure that out before this test. But can we do an XY chart? We can. Can we do a pretty easy XY chart? You can do an XY chart that is plugging values in, or what can we do? It's an inverse, yes. Can you take the XY values we already have and flip them? Yes, you can. Okay, if it's the inverse, you can take these over here and switch them. And so instead of -2, 4, 4, -2. Instead of -1, 1, 1, -1. 0, 0, 1, 1. Instead of 2, 4, 4, 2. Okay? Now, if you go back to what I taught at the beginning of the semester, I used 0, 1, 4, and 9, didn't I? Okay, so you could also have 9 and the 3s. 9 and +3 and 9 and -3. But okay, let's graph it. Now that I look back at my answer key, I actually used the 9s and 3s on both of these. Oh well. Okay, so 4, negative 2. Down 2. 1, negative 1. Down 1. 0, 0. 1, 1. 4, 2. And I guess now that I think about this, I should have set this up differently, because if you put, let me make sure we understand this, if you put 4 into the square root of x, plus or minus the square root of 4 is going to be what? Plus or minus 2, yes? The values are there. I just had to switch them. Okay, if you put 1 in, the square root of 1 is going to be plus or minus 1. So realize the values are there. Okay, so we end up with not just half of a sideways parabola, but all of a sideways parabola here. Okay. Now this is our inverse. Okay. Now, okay, a couple of things. I want to talk about the reflection line, but before we do that, let's talk about what's functions here, what's not functions. Is my original piece a function? And I just realized I called it a function earlier without thinking. It is a function. For one, my x values do not repeat. Okay? So this one is a function. What about this sideways parabola? Is it a function? No, because 4 pairs with 2, 4 pairs with negative 2. There's a perfect example. So this, the inverse is not a function. Do you guys remember a line test to determine if something's a function? So we probably haven't talked about this year then. So I'm making you go back to Algebra 1, and there's no guarantees what got taught there, what you remember, or anything like that. So, vertical line test. My original graph, it passes the vertical line test because I can draw a vertical line through the original function, and it only ever touches it in one spot. Any vertical line I draw, it's going to cross through that parabola just once. What about this guy? What happens if I draw a vertical line through my inverse? It's going to cross twice, isn't it? Okay, so we can talk about how this one fails the vertical line test. That's a way to tell if something's a function. If it fails the vertical line test, it fails the vertical line test because it touches a vertical line twice if you draw it. Okay, so that's another way. Got some ideas there? So we could, options here, fails vertical line test is one way, or we can talk about domain, or in other words, x values repeat. So if you're looking on, okay, how am I going to remember that come homework time? There's some options, as opposed to just having to guess whether or not it's a function. I know, you can make that work on Savas, but on a quiz or a test, it's a 50% because you're guessing there. Okay, one last thing before we move on. Up in the little section up above, it said that the graph of a function and its inverse will be reflections across the line y equals x. And we mentioned the line y equals x. The line y equals x is that perfect diagonal line. It goes through 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. It goes all the way through here, folks. Okay, that perfect diagonal line. You can also think of it as a slope of 1 and a y-intercept of 0. Well, sorry, I put the dots in because otherwise I won't be able to get that line in there. If I was able to take my BenQ board and fold it along that line I just drew. Like, what would happen with the graphs? They'd be shattered. That's going to be Patrick's words, right? Okay.
Well, no,
But,
you can see that.
okay, what would happen? If I fold this graph along that diagonal line, would these graphs land on top of each other? Yeah, they would. Okay? And that's something you can maybe do, you know. You can do it with your paper. You know, you can kind of try and fold it and, you know. I just can't do it on the BenQ. But so that's where functions and their inverses are going to reflect across, is that perfect diagonal line. Okay? So not that you have to graph that in there, but I wanted you to see visually what it was. Okay, did I get everything? Okay, I think I got everything I want to talk about there. Shall we try B? Let's try B. Okay, same thing. Write an equation to find the inverse, and then we're going to graph. We're going to talk about what's functions, what's not. So, f of x equals 2x minus 1. What do you know? F of x, first of all, is the same thing as y equals 2x minus 1. How do I find the inverse? Okay, y becomes x, so x equals, x becomes y, so 2y minus 1 just stays minus 1. Okay? After you get that done, what do? Our job is to take that equation and solve it for y. So to get 2y by itself, I'm going to add 1. Since it's minus 1, we're going to add 1. Are you guys okay that I started on that side? Okay. So then we have x plus 1 over here. On the other side, I have 2y. Okay. And if it's better, I can flip this. I can make this 2y equals x plus 1. How do I finish solving for y? Divide by 2. If you divide the left by 2, you're dividing the right by 2. We're going to divide everything by 2. And you can do that, so I just wrote it as each term got divided by 2. However, it would not be wrong in my book to also write it as one big fraction, x plus 1 divided by 2. Both are correct in my book. Who knows what Savas wants? Sometimes it's going to be easier one way than the other when graphing. Okay, if we clean this up, what do I have? 2y divided by 2 is y equals x divided by 2. What do you guys think of there? What's the invisible number in front of x? A 1. And so if I had to guess, yeah, because getting ready for graphing, you can leave this as x over 2, or you can think of it as 1/2 x plus 1. So either or, there's pros and cons both ways.
Is the 1 divided by 2?
Well, yeah, it is. Thank you. Okay, 1/2 x plus 1/2. My apologies. Okay, so this is my inverse. Okay, if you would rather have thought of it as y equals x plus 1 over 2, you can make that work also. Okay, that could have worked also. Okay, we have the inverse. Let's do some graphing. How do you want to graph the original, y equals 2x minus 1? Okay, can we do an xy chart? You can. What else can we do here? Is it in y equals mx plus b form? Whatever you see personally, yes? Okay, if you want to do an XY chart, you could get away with just doing 0, 1, 2. Okay. If you plug in 0, 2 times 0, minus 1, negative 1. If you plug in 1, 2 times 1 is 2, minus 1, 1. If you plug in 2, 2 times 2 is 4, minus 1 is 3. Or what if you want to do that slope-intercept? What do we know? The y-intercept is negative 1, because that's your b value. My slope is what? 2, which as a fraction is 2 over 1. Again, do you? What do you see? If you had to graph that on a test, which one, go with what you see. So let's graph it. My y-intercept is negative 1, or if you're doing XY chart, it's 0, negative 1. Slope of 2, 2 over 1. What's our phrase for slope? Rise over run. So I can rise 2, run 1. Rise 2, run 1. We can do that however many times we want, yes? Does that match up with values on my XY chart? It most certainly does. Okay. So, I'm never going to be able to get, so the idea here, I'm going to put some more dots on because I can't draw a straight line on the bin cue. Not easily. Gosh. Okay. So that's my original, yes? And while we're here, is this a function? Yes. Each x value corresponds with one y value. I'm not going to be able to get a repeat. Does it pass the vertical line test? I can draw a vertical line. It's only going to cross through once. So is it a function? Yes, it is. Okay. Now we want to graph the inverse. How do you want to graph the inverse? Can we do y equals mx plus b? We can. And that would be why you wouldn't leave it as one big fraction, but you would put it in this form. If we do y equals mx plus b, my y-intercept is 1/2. Okay, not ideal, but it's doable. And what's the slope? Also 1/2. Rise 1, run 2. Okay? What are options for an XY chart? We can plug in values here, can't we? What also could we do? Could we take our other XY chart and reverse it? If you're saying, ugh, I don't want to mess with these 1/2, this 1/2 y-intercept. Wait a minute, something's not right here. Oh yeah, never mind. Okay, so you could also reverse this if you want. Take those and switch them. Then you'd have negative 1, 0, 1, 1, 3, 2. Okay, so if I go with my y-intercept of 1/2 though, okay, that puts me right there. Y-intercept of 1/2. If I rise 1, run 2, rising 1 puts me at 1.5 over 2. It just means my points are going to be in the midpoints, okay? Rising 1, go up the equivalence of a full box, so you're halfway into the next box, over 2. Now, what if we go back and grab these points? Negative 1, 0. Well, that's left 1, up or down 0. 1, 1. And 3, 2. Those points end up going between the others, don't they? Okay, so you have options. You have options of how you graph that. Oof. Okay, so this is my inverse. Is it a function? It passes the vertical line test, yes. I can draw one line. If I plug in an x value, I'm not going to get multiple answers. Earlier, when you had plus or minus, you plug in an x value, you're going to get multiple y values. Seeing a plus or minus is a huge red flag in my brain that says it's not a function. Okay, this one though, the original was a function, and this one is a function. Okay, now, do you see the reflection across that diagonal line again? Do you see it? Granted, you have to go with, I don't know how your drawings look, but my drawings are a little debatable. Okay. If I fold those, they should land on top of each other, shouldn't they? Okay. Graphs and everything took a bit longer than what I thought. We got through the front side. That means tomorrow we have 2 topics left. One of which is taking, so this was just more graphing it. But then on the back side, we're going to practice finding equations of x's when there's a little bit more, or inverses when there's a little more math to do. And we're also going to go back and revisit Fogg and Goff. F composed with g of x and g composed with f of x. If you haven't done your homework from last Friday, it might not sound as familiar as it should. But we're going to go talk about a special relationship with inverses there. Okay? Other than that, get 5.5 done. And you can be working on 5.6. You don't know all of it yet, but you know parts of it.